Okay, so good morning. For today, I'm going to discuss how to compute moments in an indeterminate structure. Okay, so we have discussed in our previous topics no na once the structure is stable, so na kay duha ka type no, it's either nga determinate siya or indeterminate. When you say determinate, you can compute it with the three static equations: summation of forces vertical, summation of forces horizontal, then summation of moment. But if dili na gani enough ang kanang tulo para ma-prove nimo nga stable ang isa ka structure, then the structure must be indeterminate. Okay. So one method in computing the moments of a structure which is indeterminate is the method of three-moment equation. Okay. So let us say you're given with a beam. Then this beam is an overhang. But instead of duha lang ka supports, you have three supports. Okay? So dili na nimo siya madali-dali og summation forces vertical and horizontal since na naka-internal nga ruler. Okay. So let's say this is 3 meters. This is 1.5 meter. This is you're given with a load na wala kaabot sa picas ends. This is 400. Say it is 400 Newton per meter. So naghatag na ko example daan. Triangular load. In an overhang of 200 Newton. Then distance ani 1 meter, 2 meter, 1 meter. Okay. So in this case, dili na nimo magamitan og three static equations. So we have the general formula for the three-moment equation. Kung nakay point A, at least na lang kay tulo ka supports. Point B and point C. So if nakay tulo ka support, nakay duha ka lengths. So usually ang length na to L1 is kaning nasa left and L2 is mo nasa right. So the general equation for three-moment equation is moment at A multiplied by L1 plus 2mb L1 plus L2 plus MC plus 6A1A over L1 plus 6A2B over L2 equal to 0. Okay, so muna siyang general equation no in solving three-moment equation. So kaning derivation ani I will discuss it separately. So for now, ako lang sang i-discuss ang formula and ang application sa formula. So nakitulo ka moments, MA, NB, and MC, which is applicable mo nang gi-apply na to siya sa indeterminate beam. Okay, so we also have three supports. MA stands for the moment at A, MB moment at B, and MC moment at C. Mo siya gitawag og 3 moment equation. So at least nakay duha ka lengths or duha ka space, at least tulo ka support. Okay, so applicable siya for simple support or fixed end. So later on maghatag ko example sa fixed end. Okay, then this a moment at C, L2. So we always multiply the moment by the distance. 6A1A over L1 and 6A2B over L2. Kani, area 1 is the area of the moment at L1 multiplied by the centroidal distance. Always reckon or refer towards the left. So always take note, pag gamay ganing A, always to the left ang centroidal distance. Then for 6A2B over L2, A2 is the area of the moment diagram of length 2, this side here. This is for the 6A1A over L1 and this is for the 6A2B over L2. Then B is the centroidal distance of the areas towards the right. So to the left and to the right. Okay, L1 and L2, that is for L1 we have the 3 meter and L2 is 4 meters. Okay, so first you have to compute the, so unsa gipangita nato diri, compute for the moment at A, moment at B, moment at C. So first things first, kinahanglan makuha ni nimo mga values ani. Okay, so for 6A1A over L1, you have to separate this L1 and consider it as a separate simple support. Okay, so 800 Newton per meter separate as a simple support para makuha itong 6A1A. Then if diri ka mag-fix, either way asa ka mag-fix pwede. So summation moment at A, R2, this is R1, it's R2, considering a simple support siya nga separate, R2 equal to 0. So R1 times 3 is equal to 1/2 times 800 by 3 by 1/3 of 3. So computing, you have the value of R1 to be 400 Newton. So katong method of drawing moment diagram without drawing the or referring to the shear diagram. Okay, so na-fix ka sa pikas, concentrated load will have a triangular loading. Okay, so that is 400 times 3, that is 1200 Newton meter, and a triangular loading downward is a negative moment. Okay, so this is first degree. So first degree, then the shear is second degree, and the moment is third degree. So expected nga naka-curve siya. So pili value ani, that is 1/2 800. So ang area ani mo yatong kuan diri 1/2 800 by 3. So that is negative 1,200 because this is a negative moment and a positive moment ang sa ibabaw. Okay. So, okay na. So we can have 6A1A over L1. Always separate the 6 over L1 because ang area 1 og A mo ay ga-change always. Depende sa hadapit ang location o hadapit positive ba siya or negative. So 6 over L1, L1 is 3 meters. Then this A1A is the summation of the areas. So first we have the positive area. The area is 1/2 1,200 1/2 12 by 3. So this is for area 1. And then the A, so manang A niya, di ba? A1A. A niya is always refer to the left. So kung to the left ka, pila man na, that is 2/3 of 3. Okay, so minus the negative area. This is a negative area. Area of this one is BH over N plus 1. Centroidal distance, that is base over N plus 2, where N is the degree, this is the base, and this is the height. Okay, so area 1 is pilay base, that is 3 meters. Height 1, 2. So dito to mag negative dire kay dire naman to gibutang over degree, which is 3 plus 1 multiplied by centroidal distance towards the left. So to the left, that is 3 minus this one. I mean 3 meters minus kani. So muna siya ang yang A. So 3 minus base nga 3 over N plus 2, 3 plus 2, that is 5. Okay. So we already have the value of 6A1A L1. Compute this using your calculator, you'll have pilaman. So, kamo na lang compute sa inyo ha. We have 2880 Newton m squared. Since this is in ang iyang force is Newton meter multiplied by a meter para area. So that is Newton meter squared. This is meter, this is meter, cancel ang mga meter. So what is left is Newton meter squared. Okay. So next is the 6A2B. So for the 6A2B, this one, you consider the rightmost portion sa imong beam as a separate simple support. So mo lang itiban ana, separate it and consider as a single simple support. Okay, so same process. Compute ninyo ang reaction sa kuan nga diri ta mag-fix. Ngano man kay kung diri ka mag-fix, pwede pang gihapon pero mag-add up ka og paretong sa double integration, magdungag ka og isa ka beam diri, continuation, then mag-add pug ka og pang-equate niya sa ubos. Okay, so di na nato na elaborate ha. na-learn na ninyo sa double integration. So dirita kay para di na ta dungag pa og another portion sa sa load. Okay, so summation moment at R2, dito sa this R2, this is R1. Equal to 0. So R1 times 4 meters, this is 1 meter, 2 meters, and 1 meter, times 4 is equal to counterclockwise 500 times 1 plus 400 times 3 times 3 halves. So R1 is 575. Okay. Gamit yapon mo kalkyo ninyo. Okay. So na kay R1 nga 575. Karon makadraw na ka og moment. So that is concentrated load that is triangular. That is 575 multiplied by distance 4 meters. So you have 2,300. Okay. This one is negative concentrated load, that is negative triangular, which is 500 times 1. Negative and positive. So kung may lain, you have the uniformly distributed, which is downward, still negative. This is a 0 degree. The shear is first degree, and the moment is second degree. So projecting this one here, you have a parabolic second degree. Value diri sa ubos, yung magnitude is 400 times 3 times 3 halves. So you have a negative 1,800. Gusto nyo mong equate, equal sila, si negative ug si positive. Okay. So we have 6A2B over L2. Still, you can separate this one or extract. L2 is 4 meters. So area 2B, again area 2. So area sa kada isa multiply by centroidal. Okay. So for this one, this area, that is 1/2, 2/3 times 4. Then ang B is always refer or reckon towards the right. Pag 6A to B, to the right ang B. A is to the left. Okay, so muna yung timanan. So B towards the right. So that is 1/3 of 4 meters. So that is 4/3. Minus another A to B. This one. Area is 1/2. 500 by 1. Then this B saman 1/3 of 1 meter. Okay, another A to B. Then this one, area is BH over N plus 1. Base is 3 meters. Height is 1/8. Again, di na ito mag-negative. Kaya gibutang na nato diri ang negative. N plus 1. 2 plus 1, that is 3. Then, this one is the B. Base over N plus 2. So that is 3 meters. N plus 2. 2 plus 2 is 4. Okay, so pili value of 6A to B over L2. We have 7,050 Newton m squared. Okay, so na kayo mga values ani. So kanina lang tulo. Moment at A, mag-solve na to. Kinamang kay overhang. Pag na kay overhang, automatically na ay moment sa simple support. So take note of that. Pag na ay overhang, there is a moment at the simple support. Pero pag walay overhang sa end supports, automatically the moment is 0. Same goes with the simply supported nga beam, di ba? Moment at A and moment at B puro 0. Moment at the ends 0 kung simply supported. Pero pag dili simply supported, dili na siya ma-apply kung fixed end siya or na ay overhang. Okay, so MAL1 ano na lang. Moment at A is that is a negative moment since ang imuhang beam will bend downward, concave downward, which is not the concave upward. Pag butang nimo na ana ang bending, so ang bending is not the conventional bending, so that is a negative moment. So negative 200 times 1.5, okay. Okay lang, ito na lang na yung niya. Then moment at C is 0. Moment at the end support, sa simple support without overhang, 0. Pag internal moment, nagyod, no? Kaya naman kay mga loads nga dili equal. So moment at C is 0. So substituting it here, so MA, that is negative 200 times 1.5, then L1 is 3 meters plus 2 MB, where moment at B is unknown. Then L1 plus L2 is 3 plus 4 plus moment at C is 0. L2 is 4 meters. So automatically 0. Plus 6A1A L1, that is nakuha na to gaya na to 880, plus 6A2B over L2 7050 equal to 0. So you only have one unknown, which is MB. So using your calculator, you have moment at B equal to negative 645 Newton meter. Okay. So moment at A, negative 200 times 1.5 is negative 300.